Hello friends, welcome to Unacademy, which is largest online education platform for GATE Computer Science and Information Technology. And myself, Maleshum Devasane, here I am going to take the compiler design, theory of computation and C programming classes on this channel. In this session, I'll be discussing mainly the bottom-up parsing, where we are going to begin the concepts of bottom-up parsing slowly to understand how we can build bottom-up parser. And most of the concepts will be covered today, and let's begin our today's session to know about bottom-up parsing. And before beginning bottom-up parser, as usual, let me introduce myself. If anybody is attending this session first time, please let me introduce to you myself. Guys, I have secured only rank 119 and 210 in GATE exam while I was studying in final year and third year respectively. And then I have completed MTech from IIT Bombay. Immediately I have started taking the GATE classes for computer science. Here I have experience in TOC, compiler, programming, other subjects too. And you can use DEVALIVE as a referral code to get the subscription for Plus or Iconic. And what is the advantage if you use my referral code? It is one thing, you will have a 10% discount. Additionally, you will have the guidance from me to crack the GATE exam. I'm going to talk about the plans, the subscription plans for both Plus and Iconic, which is the best for preparation too. And if you are visiting Unacademy anytime, you can find the classes, free classes on C, TOC, compiler and algorithms. You can watch them. And guys, what are the advantages of coming to Plus? You have complete courses, revision, crash practice and previous year doubt solving courses and test series. All of them are under Plus. Then why do you prefer Iconic over the Plus? The reason is, if you look at the Plus, you have most of the benefits, no doubt, live classes, and every week there will be a test on weekend, and then doubt solving session on every fourth day. And apart from this, the Iconic will have a personal coach, a live interaction with your coach that makes you to learn and to cross check every time when you have the requirement of guidance. And also you will have a study planner, study booster session and personal test analysis preparator, separately created study material for you. And these all benefits are there under Iconic. So I prefer Iconic over the Plus because I want to crack the GATE exam. I don't want to waste my time. So better to go for Iconic. And there is a marginal difference between them. Let's look at the Plus. What do you have? What is the difference between Plus and Iconic? First, Plus, if you are not able to pay much amount for Iconic, the Plus is obviously suitable, like 1 year, 1.5 years, 2 years. If you are studying third year, go for 2 years. And if you are studying in final year, you may prefer 1 or 1.5 years. So as per the subscription month that you are taking. And this is a 1 year amount 27,225 if you use DEVALIVE, whereas if you go for Iconic for 1 year, you will have a 45,225. Even though there is a difference between the 1 year plan between Plus and Iconic, and there is a guarantee to crack the exam because of the lot of guidance, lot of support from Unacademy will be there to crack the exam. So this is the most important thing, that we prefer Iconic rather than the Plus because you will get more advantages when you are preparing to the Unacademy. Okay. Now similarly, you look at 2 years plan, which is 66,600. Right. Yeah. Satyajit, good evening. Sandeep, good evening. Vaibhav, good evening. Oh, Vaibhav. Vaishnav, good evening. Yeah, guys. And also you can join our Facebook group GATE Aspirants, and we have Telegram channel to subscribe, guys. And we have various YouTube channels you can share with your friends, and these all YouTube channels will help you to study self preparation if you want to do. And this is the channel where you can learn every subject for the GATE exam. So please follow our channel and visit regularly to attend the classes. And daily we have classes, minimum 3 to 4 classes are there, and you can prepare your GATE exam with our channel. And please subscribe if you have not done it, and please share with your friends, and do not forget to like the session if you are joining late. Yeah, let's begin today's session, guys. And please like the session, guys. I'm waiting for your likes. And in this session I'm going to talk about these topics are already completed, guys. Lexical analysis, syntax analysis, we have top-down parser completed, and about context-free grammar. And today's session, especially we have learned top-down parser, then what is the difference between bottom-up and top-down parser. Then we will enter into bottom-up parser, where we will study the one important word, that is reverse of RMD, also called as RMD in reverse. Okay, we have studied theoretically derivation of a string. Either you can use LMD or RMD, but here we don't use RMD to implement bottom-up parser. We use the reverse of RMD. Remember that. If anybody asks what is the approach followed by bottom-up parser, you have to say reverse of RMD, but don't say just RMD. Yeah, we will see types of parsers. Then we'll go for mainly today LR0 and SLR1 grammar, how to understand. Let's do quickly. What is the difference between top-down and bottom-up parser? Top-down parser is going to follow the leftmost derivation to generate the parse tree, and bottom-up parser follow the RMD in reverse. RMD in reverse to generate the parse tree, and both are parsers. But when you look at these two parsers, top-down parser is less powerful compared to the bottom-up parser, because bottom-up parser can understand more syntaxes compared to top-down parser. Yes, we have various number of parsers in top-down and bottom-up. You must relate them properly. Yes. So when you look at the by default parsers, yes, bottom-up parser is more powerful than top-down parser. So let me discuss that slowly. And in top-down parser, we use prediction is the concept. If you go for LL1, prediction is the main thing, prediction. But when you go for bottom-up parser, we use shift and reduce. These two actions we are going to use to parse an input, and this will help you to perform reduction. So reduction is the main concept in bottom-up parsing. So to understand the bottom-up parser, first you should know what is RMD in reverse theoretically. Practically we will see later. Yes. So have you seen the LMD in practically? Yes. In the previous session I have explained how the algorithm works with the help of this stack. Right? That was the leftmost derivation. That is a practical implementation of the LMD. Yes. Let's look at what is the difference between LMD and reverse of RMD theoretically. Guys, if I want to derive, let us string, this is your program, string I want to derive AB. So what LMD does, you will start with S and you will substitute AB, and then AB here, first I have substituted S, then here A, that is LMD, then AB substitute with small a. Then we have capital B is the leftmost non-terminal. Then we will get finally AB. So we have substituted like S, we have substituted with AB, then capital A we substitute with A, then capital B we substitute with B. So if anybody asks what is the LMD non-terminal order, you have to say S, comma A, comma B. This order we have substituted. You look at only this one, S, A and B. Yes, that is the order we have substituted. That is the LMD order. But when it comes to reverse of RMD, theoretically very difficult to write directly. So LMD approach is you start with S and you derive your string AB. But reverse of RMD, you will start with your string, you will try to reach your start symbol. So before understanding that RMD, let me explain first. Before understanding reverse of RMD, let me explain first reverse of rightmost derivation. First, let me explain. Everybody knows what is RMD. We have practiced in the previous session too. That is S derives AB, and here after S we substitute B rather than A because A was the leftmost, B is the rightmost. So now we go to B. And here we get capital A, small b, and then we will go for small a. So this is called as rightmost derivation, guys. But we don't want this. What we want reverse of RMD. So before understanding this reverse of RMD, let me explain. Here we have substituted S with AB, here B with B, and A with A. If anybody asks what is the RMD order, you can say that, okay, first S, then B, then A. This is the order, right? We are going to substitute S, then B, then A. That is the order we are substituting here. Yes. Good evening, Vaish. Now, what is the reverse of RMD? The concept, theoretical concept. We will start with AB. Can you see that? Yes. And we'll try to reach S somehow. How? The exactly reverse approach of RMD. Exactly reverse approach of RMD. You can see RMD and you can just do that. This is the reverse of RMD. RMD we go down by substituting, but now we will perform reductions. How the reductions are performed? We will look at that production as it is, guys. Now slightly changes the concept. What kind of concept changes now? Let's look at that. Here this is called as handle. That is exactly RHS of productions. Can you see that? The RHS of productions are actually called as handles now. Handles, guys. This is RHS of a production, and that handle is replaced. And how? It's a very difficult process, guys. This A is replaced with capital A. Then this B is going to be handle, and that handle is going to be replaced with capital B. Capital B. Then this is going to be handle in sentential form. Then this is going to be replaced with S. Yeah, this approach is slightly difficult in theoretically, but practically we have the algorithm to do that directly without using RMD concept. But theoretically you require RMD concept to understand the reverse of RMD. If anybody asks what is the reverse of RMD order, then you have to say first A, then B, then S. This is the reverse of RMD order, because first we substituted replaced with A, then we replaced with B, then we replaced with S. Okay, so it is just a reverse of RMD order. Whatever you get SBA, just do the reverse, you will get ABS. Okay, and I hope you understood what is the RMD and reverse of RMD. Guys, if anybody watching this video, please just spend 1 or 2 seconds to like the session. I can see that, please, you are watching, most of you are watching live, and please go to the video and like the session, guys. Yeah. Now we have top-down parser and bottom-up parser. You know that top-down parser concept, that is a TDP, and bottom-up parser BUP. In the top-down parser, if S is a start symbol, we will start from S. We will try to derive your string. That is your sentence. That is also called as sentence. And in bottom-up parser BUP, then we will start with your string and we will try to prove that I can reach S somehow. Here we use the prediction we call substitutions. The predictions will help you to perform substitutions. And in bottom-up parser we use reductions, because we approach from RHS to LHS. Yeah, we require to find RHS and we will replace with LHS in bottom-up parser. Okay, so this is the main difference between top-down and bottom-up parser. Here we use LMD concept, here we use RMD in reverse. Do not forget in reverse this concept. Okay, let's look at the types of bottom-up parsers. And guys, here bottom-up parser is also called as SR parsers. Remember that? SR parser. SR parsers nothing but bottom-up, that is shift reduced. Shift reduce. SR means, because it's going to use shift and reduce actions. And here two kinds of parsers are there. There is a bottom-up parser also called as SR parser. Now we have two kinds of parsers, LR parsers and operator precedence parser. And you may have n number of parsers. Even CYK parser is there, operator precedence parser. And guys, if you look at the parsers, the top-down parser, basically LL1 parser I am talking about. These LL1 parsers, they take the time complexity worst case order of n, but when it comes to bottom-up parsers, the worst case time complexity comes to order of n cube. They use dynamic programming concepts basically. So if anybody asks this LL1 parser and LR1, this is bottom-up parser concepts, and basically this depends on the order of n algorithm. If n is the length of your input, and bottom-up parsers, they do the syntax verification with the order of n cube. So this is the main difference. The reason behind it, bottom-up parser is more powerful, so it has to analyze a lot of things inside. Anyhow, don't worry about time complexity now, because you don't know even algorithms too. Now in LR parsers, we have LR0 parser and we have SLR1. LR0 theoretical, practically we don't use LR0, and LR, and what are all this we will see slowly. CLR1, also called as simply LR1. Okay, just LR1 is enough. C represent canonical, like exact. And here LR, look at that, all of them they are using SR, already I told shift reduced, and LR, what is L and what is R? L represent like top-down parser is the left to right scan of your tokens input, left to right scan, and R represent the reverse of RMD. Don't say just RMD, it is the reverse of RMD. Then why we use here S? Why we use here is it is simple. LR. What is LA LR1 means? It is look ahead. LA means look ahead. LR1. And what is CLR means? It is a canonical. LR1. Okay, everybody has name, and 0 means no look ahead. 0 means no look ahead, like LL0, and 1 means yes, we have a look ahead process but a simple calculation. So slowly we come to this conclusion why these 3 parsers have 1, and guys other parsers are also there, like LR2 and LR3. So many parsers are there, but we are not going to study all of them, right? So we have so many LR parsers are there here. Okay, so this is the types of bottom-up parsers we have, and out of them we are going to look at the 5 parsers, like 4 LR parsers, 1 operator precedence parser. Okay, now configuration of LR. Now don't worry about the precedence parser, we will see slowly that. First we will focus on LR parser. What is the configuration of LR parser? Like exactly LL parser, LL1 parser. What was that? Okay, we have input. Did you remember that? We have input and we have a stack. and we have algorithm, and we have a table too, and we have a connection to understand, and this may produce output, that's okay. And your input is here. This is your stack, and this is your algorithm. You can say reverse of RMD algorithm. And we have a table, and there is an output, right? Yeah, we'll produce output also. That's a parse tree. We'll produce output as the parse tree. You can say that. By understanding reverse of RMD approach, we will produce a parse tree. Yeah, this is the configuration of LR parser. Here, first if you want to do the parsing, now you should build a table, but table we can't build. We have to do so many things, guys. Now look at, if you want to build a parser, whether it is LR0 or SLR1 or sorry, whether it is LELR1 or CLR1. So anything, first we should know about grammar. The grammars, guys, here we have LR0 parser, SLR1 parser, and LELR1 parser, and CLR, that you can call as simply just LR. And this parser requires LR0 grammar. If you have LR0 grammar, you can build LR0 parser. This parser requires SLR1 grammar, and this parser requires LELR1 grammar. Grammar is different from parser, and we use this grammar to construct the table. Then that table we use in the parser. So what is the approach we are going to follow? First we need a grammar. Even top-down parser also, guys, LL1 grammar. Then we build a table somehow, and then we went to parser with the help of algorithm. The parser cannot be built directly without understanding about what structures you need. So manually you need to do lot of work, that is grammar. First grammar required, but that grammar is related to your parser or not. After constructing the table, you will understand. If there are multiple entries are there in the same cell, then we say that grammar is not related to that parser. So this is how we understood about the parser. Okay, let's focus on now. Now I want to build LR0 parser, guys. I want to build LR0 parser. Is that easy? Okay, now LR0 parser is theoretical. I want to build. So first, what do you do? Write LR0 grammar. How do you write it? Very, very difficult. That whether you have written or not, you will understand after some time. Second step, you construct some diagram like DFA, or you can find sets or set of LR0 items. Both are same. Collection of LR0 items, canonical collection. 3. And you will understand the grammar is LR of 0 or not by looking at a DFA. Then you can construct a table. If the grammar is LR0, then construct the table. That is LR0 table we call. Then implement the algorithm. So algorithm, that is a parsing algorithm required. There is LR parsing algorithm. Then we are ready with our parser. Now we have a table, we have algorithm, we have a input. Now we can parse with the help of algorithm and table. So this is the whole story, guys. Not at all easy. Directly you can't understand what is LR parser. So slowly we will begin. Like LL1. Did you remember our top-down parser? What you have done? First LL1 grammar. Then whether it is LL1 grammar or not, you may know after consulting the table, or you may know before that. First write LL1 grammar, then consult the table, not directly. First compute first and follow set. That will help you to consult the table. Once you consult the table, then we have an algorithm, that is leftmost derivation, practical algorithm to understand the whole parsing concept. Okay. Now look at that. We have two parsers now, LR0, SLR1. LR0 grammar we take here SLR1 grammar. But diagram is same for both. You can use the same kind of diagram for both, right? But whether it grammar is LR0 or not, this diagram will help you. If the grammar is LR0, we will go for table. If the grammar is not LR0, we will write the grammar correctly, then we will consider the table. And for SLR1, same concept. Even the diagram is same, but the way you consult the table is different. The way you understand the SLR1 is different. Remember, only diagram is same, but both sides we have LR0 state diagram, but the way you understand that diagram will be differed in both. So that we are going to look at. Then algorithm is also same, and this is same. This algorithm is also same, but remaining are different. This table may be different. It depends on the grammar, may differ. And of course, LR0, SLR1, no need to be same, may differ. What is the relation between these two grammars, guys? There is one concept. Every LR0 grammar is SLR1 grammar. But SLR1 grammar need not be LR0, because SLR1 parser is more powerful. Here if you look at LR0 parser is less powerful than SLR1, because SLR1 parser can understand more structures, more syntaxes, so that you can add more grammars too. Yeah. Right, there is no relation between, guys. Why are you relating with regular grammar? Hana? Yeah. You don't know what is LR0 grammar. Ab kaise karoge yaar? You don't know what is LR0 grammar at? Start ही नहीं हुआ, आप end में जा रहा है. Please relate this kind of questions at the end of the concepts. Concept in पता नहीं यार. LR0 grammar. Do you know what is LR0 grammar now? Tell me. Right? So we have so many things to understand what is LR0 grammar. Just you can't understand first 10 minutes, and you must spend much time what is LR0 grammar. Wait to relate. I can say that there is no relation between regular grammar and LR0 grammar. Remember that. If you know about the regular grammar. Okay. Now, first we are going to build LR0 parsing state diagram. Vaibhav, start nahi hua topic questions. Okay. LR0 parsing state diagram. First, you should know what is the state diagram. Then you will know whether your grammar is LR0 or not. This is the only way you can check, guys. But some people have a beautiful techniques like, sometimes you will get immediate answer. If the grammar is ambiguous, that grammar is not LR0, guys. Here there are certain relations between ambiguous and unambiguous, guys. And whatever you learn like LR0 grammars, LR0 context-free grammars, remember, not 1, 2, 3, infinite grammars are there here. And all these grammars are inside SLR1 grammars. And all these grammars are inside. पहले ये पढ़ना पड़ेगा ना आपको. ये पहले ग्रामर ही आता नहीं, इनको रिलेशन चाहिए. क्या ये डाउट क्लास है क्या? ओके, ऑलराइट. LA LR1 CFGs, ये समझने के लिए आपको बहुत टाइम लगेगा. पहले ये ऐसे क्यों है, right? We have here CLR1 CFGs, not one, infinite. And all these grammars are, if you look at, all these grammars are inside unambiguous CFGs. Class I am talking about unambiguous CFGs. That means every LR0 is unambiguous. Every LR0 is unambiguous CFG. I'm talking about a grammar, I'm not talking about a parser. Remember, LR0 grammar is different, LR0 parser is different. Have a clarity what we are understanding here is also unambiguous, because this class is inside unambiguous class. Everybody? Yeah. And this class is going to take much time to understand, because you have not seen even one LR0 grammar. Then how can I relate LR0 and SLR1? So slowly we build our knowledge how this LR0 grammar is always SLR1. We have other relations also. Every LR0 CFG is always SLR1, and every SLR1 CFG is always the LELR1. Every LELR1 is always LR1, and every LR1 CFG is unambiguous. Every LR1 CFG is always unambiguous. But converse is not true. Unambiguous need not be LR1. Look at that. If I'm going to talk about this grammar, let's say G1, and here so many grammars are there like that. Okay, let me give some different names, guys. Okay, A, B, C, D, F, something like that. Here A1, A2, A3, they are grammars, not productions, guys. And B1, B2, B3, and so on. And C1, C2, C3, and so on. And D1, D2, and D3. And let's say G1, G2, G3. And if we talk about A1 is LR0, A1 is also SLR1, A1 is also LLR1, A1 is also CLR1, A1 is also unambiguous. So if you want to talk about one A1, this grammar is LR0, is SLR1, is LLR1, is also unambiguous, because it is there in all the boxes. It is there in all the boxes, guys. It is there inside LR0 class, inside SLR1, guys. Similarly, you can relate every grammar with others. Okay. Satyajit, and why are you worried about yaar? To pehle hi chahiye sabko. And guys, anybody want to relate with LL1? That class is something like that. You will have. Okay, let me use different color. लास्ट में क्या पढ़ोगे यार? अभी तो सब रिलेशन करके जाओगे, तो लास्ट में क्या करोगे? This is the LL1 class, LL1 CFGs, and it is inside CLR1, inside LR1, but no relation with LELR1, SLR1, guys. The LL1 CFGs is inside the class of CLR1 class. Okay. Right. Don't worry, all the relations. Okay, so this is, at the end of the topic you have to learn, not now. Every one you will have an example to understand, but now we are going to see what is LR0 diagram. If you want to learn LR0 diagram, first we will start slowly. Start. Now assume that nothing is started, nothing happened so far. We are just starting this BottomUp Parser, just starting, and that is also LR0 parser. In the LR0 parser, I want to understand whether my grammar is LR0 or not. First, write augmented grammar. What is augmented? Just wait. And you should know the types of items, and you should know how to compute closure set and go to set. If you don't know, then you can't construct this diagram, and you should identify SR and RR conflicts. ये पूरा करने के बाद if every state has no conflict, then we say grammar is LR0. If any state has a conflict, that is, there are two conflicts, SR and RR. I'm going to talk about, that is, S means shift, R means reduced. What is that? We will see slowly. If any conflict present in the diagram or any state has any conflict, then we say the grammar is not LR0. Right? The whole story to talk about whether the given grammar is LR0 or not. Whole story. But before drawing the diagram, just check. If the grammar is ambiguous, no need to draw the diagram. Directly you can answer it is not LR0. But if the grammar is unambiguous, no guarantee whether it is LR0 or not. Because unambiguous class very big. Outside LR0 class also there are so many unambiguous grammars. Okay, now let's begin. What is this diagram? First, what is augmented grammar? There is a special production. And you may ask, sir, why do I take that? Because that is how your parser stops. If you want to stop your parser, and that production is important. That production has a name. I will talk about that slowly, guys. That production has a name. I will talk about that. So this is called as your augmented grammar. This is the given grammar. If given grammar is already having that first production, no need to consider. This is augmented grammar. What we have added, just add one production. What is that? S dash to S. S dash derives S. Right? What we have added from given grammar to augmented grammar, how to get? Add just one production. What is that production? We have a name. We have a name, guys. Okay, that name I'm going to talk about. Here, when we are building the diagram, when we are considering the diagram, we will have LR0 items. What is this LR0 items? There is a dot in every production to understand the progress or to understand what portion of the production is scanned to understand the derivation, to understand your reduction process. Okay, what is that means? Example, you have, let's say, here one production I'm taking, you can take any production. You can take any production. Suppose I have, look at here, S derives, I can keep a dot before AB. I can keep a dot after A. That depends on our construction. I can keep after AB. And guys, and everybody is different. So instead of explaining this example, I will just take another example to understand. I don't want this. Let me write something. X derives dot, let me write something, Y, A, Z. And after some time, the dot can move just after Y, and then after some time, don't worry how it moves now. I just want to talk about the items. Now guys, we know one thing, that is X derives Y, A, Z is a production. But what are all these called as? Items. This all are called as items. Which items? LR0, because I'm not maintaining any follow information in these items. Just zero information, zero look at information is there. But it is a production. It is a production where the dot is placed in the production. Dot exists in the RHS side. But look at, guys, dot exists in which position? That is very, very important. Dot exists in which position? Guys, dot exists in which position? That I don't look at before the dot. I just look at who is just after the dot. Is this non-terminal? Is this terminal? Just look at who is immediate symbol after the dot. And who is here? Non-terminal. Non-terminal. And sorry guys, last one I have taken as a same as the previous one, right? A Z and dot. And after dot, nobody is there. And we have the name for each production, guys. When you have a non-terminal after the dot immediately, then that item is called as state item. State item. And there is incompleted also. This is called as shift item because that is going to help us. Why? Because A is a terminal. When a terminal present just after the dot, that is called as shift item, and this is called as state item. And last one is called as reduced item because completely reduced, also called as completed item, and these three are called as incompleted. So we have two types of items, completed, incompleted. Incompleted items, further there are two types, shift items and state items. Shift means after dot the next symbol is the terminal. State means after dot we have immediately non-terminal. I hope you are clear, everybody. Yes. And these are all items we are going to see in the diagram. We are going to see in the diagram while we compute. Abhi the computation start in हुआ, basics before construction of the diagram. First we need augmented grammar. Okay, we add production, and that production basically will help to accept our or to stop our parser. This production will help. It helps to accept our input. It is actually when we write something in the future, s dash derives dot s, we call the special item, sorry, s dot we don't call reduced. What we call is acceptance item. This is acceptance item because we are going to accept when you look at that. So even though it looks reduced item, dot is at the end of the production, we don't say it is a reduced item. It's a special reduced, it is acceptance item. Yeah. Is that clear? Yeah. Clear? Okay. Now let's move to construction. Okay. Now guys, we have to understand how to construct the diagram. Now I'll help you to construct, then I will tell you what is the closure and go to here. So let me begin. Do I have a diagram space? Yes. Is the same example? Oh no. So let me start constructing the diagram for this. Okay. LR0 diagram. LR0 DFA. We say LR0 diagram or DFA because we construct using deterministic concept here. And I have a grammar that is given to you, which is very simple one. Okay, I am taking that augmented production. Now here we are going to start the construction, guys. The initial state is going to apply closure that is called as s dash derives dot s. And what is closure? Don't worry. And what is the algorithm is to construct the diagram. If you have a non-terminal just after the dot, if we have non-terminal just after the dot, write all productions of s here. How many productions of s are there? Only one production. And guys, yes, same. That is, and keep the dot in the beginning. And now see, the s I have written because of this s. Now we are going to keep a here because of this a. Because of this a, I am going to write a productions by keeping the dot in the beginning. And b we don't write. B we don't write here because b is not there as the immediate symbol after the dot. So this is initial state, guys. This is the initial state. And this is also called as closure of s dash derives dot s. And if you give the name I0, the I0 is called as closure of s dash derives dot s. If you try to find the closure, you will get the set of items. You can represent as a set like itself, and S derives dot AB and comma A derives dot A. You can represent as a set or you can represent as a state box. Right. Sai Sandeep, that is what I am talking about. Right now, you don't understand why we are going to use this, because while pausing, you will understand what is the importance of this, because we are going from bottom to up. How do you know that? We are moving dot from here to here, something like that. Then when dot moves at the end, somehow the dot is here. So S dash is there to help us. S dash is there to help us. Okay, we have accepted. And it is the reverse of RMD. That's why we are tracking the dots here. Something like that. Initially we start with dot AB. Okay, after some time that dot moves here, and after some time the capital A comes there, and after some time the dot moves further, and after some time and AB comes, and after some time S comes. Now we know it is accepted. But who is there to help us? That S dash is looking at, did I get S dot or not? Right? S dash knows that, okay, that is actually we reduced to, that's internally it happens, don't worry about it. So S dash knows that, okay, I'm looking at S dot, that means I have accepted. So that is internal implementation, don't worry about much. Okay guys, now come to the point. Now this is initial state of the DFA. Initial state of the DFA. Now why do you require to construct the DFA? Because you want to construct the table. If you want to construct the table, you must need this diagram. This diagram helps you to construct the table. And what is this diagram? Like a deterministic finite primitive. Here, look at the symbols. Look at the symbols. I have S, I have capital A, I have a small a. And for the small a, there is no further derivation or further addition of the items. Remember that, because A is the terminal. And because of these symbols, we must have the three arrows. Three arrows. One for S, one for A, one for small a. But never do one thing. Never do one thing. Don't keep two arrows for capital A. Even though there are two productions, they have the capital A just after the dot, then don't keep the two transitions for the same A, because it is a deterministic diagram. Deterministic diagram. Now what is the meaning of reading S? Because the dot is going to move. This is what the special item. If you come to this position, means your syntax, you have verified the syntax of your program. So compiler successfully verified. So this is one state. Now why I am closing it? Because after dot nobody. So it's reduced completely. And it's an acceptance item. And S derives A dot B. Guys, don't close it now, because B you can see now. Because of that, you have to add all B productions by keeping the dot in the beginning, and that is. And now look at this B also, but that is a terminal. You can't write any new productions. Now this is a new state. And next one, A derives A dot, and after dot nobody is there. So dot is actually, we are trying to move from here to here by shifting. Okay. Now here there is no further transition because there is no symbol after the dot, and here B is there and small b is there, and when you read capital B you will get AB dot. That's all. After dot nobody there, and B derives B dot, and that's all. And this is what we have to compute as LR0 diagram. This is LR0 DFA. Now why we call here we have canonical collection, that is set of canonical collection of LR0 set of items. LR0 items, you can say simply LR0 sets. Okay, just one word I am writing here, collection of set of LR0 items. What is that means? I'm going to talk about, guys. Look at each box. Each box, I'm giving a name. I0, I1, I2, I3, I4. And there are 6 states, right? I0 is called as what? A state. But is also called as set of LR0 items. What is that called as? LR0 items. One set, it is one set. Like every state is called as one set, and that set has LR0 items. You can say that it is a set which has S-dot-S, which has S derives dot AB, which has A derives dot A. Can you see that? Every item is LR0 item. We have 3 LR0 items. So we have set of 3 LR0 items. And that set is called as a state. And we are going to collect all these states. That is collection of the states. Collection of the states. Right? So this is nothing but these states. Collection of states. Each state is a set of LR0 items. Okay. Now, what is I0, guys? Let me tell you. I0 is called as the closure of S dash derives dot S only. And that is a set. And what is I1 called as? I1 called as go to function on I0 by reading S. What is I2 called as? I2 is the go to function. Wait, guys. Go to function on I0 but reading capital A. Similarly, you can represent everybody. Like what is I3? Go to function. Then go to also gives set of items, but on I0 A. And what is I4? You numbered it. Tell me what is that? Go to on I2 by reading capital B. And what is I5? Is go to on I5 by reading small b. Right? Every state has a set of items. Right? Each box is called as a set of items here. Clear this point? Yeah. This is LR of 0 at DFA, guys. And guys, this is not enough. We don't know the grammar is LR0 or not. So what we do? We are going to check the conflicts. How to identify grammar as LR0? We have constructed somehow. We started with S dash derives dot S and we have expanded somehow. We got the diagram. But grammar is LR0 or not? These conflicts we have to check. SR conflict means if state has both, any state has both shift item and reduced item. And I told you what is the shift and reduced already. Then we say conflict. SR conflict, guys. You call it as SR conflict. What is reduced conflict? If a single state, same state, if the same state has at least 2 reduced items, has at least 2 reduced items, then definitely it produces RR conflict, no doubt. Guys, इसको DFA बोलना क्या है यार? Guys, इसको दिखाओ क्या? I0, yes, and A, and remaining you may assume you are going to dead state now. Small a, I no need to show yaar DFA. I3, it is the deterministic motion. Everything I no need to say exactly that we have done in DOC. Remember that too. And why this is DFA? This is how we have. Everybody, now all the missing symbols, of course we never read them. From I0 we don't read small b because we never want it. If anybody reads, you go to dead state. Is it DFA or not? Yes, it is DFA. It is DFA. Why it is DFA? Because from any state I never have, like I0 is there. Do I have 2 transitions on S? No. If you have two transitions, that is not a DFA. We never do that at all. Clear this point? It is DFA. If you want to show that it is DFA practically, on missing transition, you go to dead state, over. From every state, for every input symbol, exactly one transition, you can show that. All right. Now guys, understand what is SR conflict, what is RR conflict. So I'm going to explain here. Do you have any SR conflict here? Example guys, example. Do you have any SR conflict, RR conflict? Guys, remember, single state never produces a conflict. Remember that. Single item never produce a conflict in bottom-up parser. Never produce any conflict. Single item never produce. If I have a state in which only one item is there, no conflict at all. No conflict. To produce a conflict, at least two items. At least two items. Now guys, here, any reduced, because look at SRRR, reduce is must. Two shift items never produce a conflict. And guys, we have reduced, look at that, single item, no conflict, single item, no conflict, single, no conflict. So only there is a chance I0 and I2. But I0, there is no reduced item. I2, there is no reduced item. So no conflict possible. So this grammar is LR0. This conclusion comes at the end. This grammar is LR0 because I have no conflict here. I have no conflict. So to understand this, we should practice very quickly, guys. Let me show you. I have the second example. I'm showing you very quickly, guys. Very quickly, dot S and S derives dot AB and S derives dot BC. If it is taking much time, you can also do like this. Keep the dot here and write bar dot BC. Now, because of S, we have written S productions. Now, because of A, you have to write A productions too. And because of this B, you have to write B productions too. But this A is terminal, so we never have a production for a terminals. So this is the initial state. Now quickly, yes, don't forget, capital A don't forget, and capital B don't forget, and small a don't forget. These are the only symbols we have from this state. They are go-to functions. And S dash derives S dot. Dot के बाद कुछ नहीं है, तो close it. And S derives A dot B, because dot just moves from here to here. That's all. And close it because there is no other productions comes here. There is no other production. B dot C. After dot terminal is there. That's why I'm closing here. After dot terminal is there. Look at that. If non-terminal is there, I could have expanded that. And A, be careful, guys. There are two A's. So both must be read into the same set. After that, nobody there. Look at, guys, we have two A's. Yes or no? After dot, we have two small A's. Two productions are having small A's. And completed, guys. Here B, one item. Here C, only one item. And that's all. 1, 2, 3, 4, 5, 6, 7. Total 7 states are there. Total 7. Now guys, let me name it to speak about them. I0, I1, I2, I3. You can number as per your requirement. No need to number like this. Now guys, if you look at I4, state I4, did you see two reduced items? I4 has two reduced items. It means it has RR conflict. Or I4 as RR conflict. Everybody, and look at I0, no conflict because no reduced item. I1 is acceptance item, that is not called as reduced here. And I2, I3, I5, I6, I1 all are having single items. Single items never produces a conflict. So just look at I0 and I4 only. If there is any conflict, only from I0, I4. So this grammar is not LR0. It is not LR0 grammar. How do you know that? Because I identified the conflict in I4 state. Everybody, And look at the next example. We have another one, very simple one. And keep this, do not forget .s. We always keep that. And because of s, we will write all s productions. One is .a, one is .epsilon. And this is initial. And you know, s we have a, but we never do epsilon transition because it is deterministic fundamental. In deterministic fundamental, we only read symbols. Epsilon is not a symbol. So here, remember that epsilon dot, all are same. Means it is already reduced. It means, please, when you have a dot, no need epsilon. Just you will have a dot. So no need to specify epsilon. Now dot is visible. Now epsilon is not required. Epsilon is not required because epsilon is not a symbol. Epsilon means no symbol, no symbol. Okay, now s dash derives s dot and s derives a dot. And look at guys, do you have a conflict? Yes, this is the shift item. This is the shift item and this is reduced item. And shift reduced both are in the same state. Shift, and guys, this is not shift item, this is a state item. So don't involve that state item. Shift item and reduced item both are present in the same state. Both are present. So what we say? SR conflict. So given grammar is not LR0. Not LR0 grammar. Okay, so I hope you understood today LR0 grammar. In the next session, I'll be beginning with SLR1, but SLR1 ready for that, you will have the same diagram, only the way you check the conflicts is different, guys. Here, in the same 3 examples, I can do that, but tomorrow we will do again. So SLR1 construction, then LELR1, then CLR1. So in the next session, I'm going to talk about the SLR1 grammar. How do we? So if you want, I can explain now, guys. That's going to take a little bit of time. That's okay. Shift item is going to look like this one. This is a terminal, and reduced item which looks like this. Look at the dot and look at terminal, and this is called as shift item. This is called as reduced item. And when you have this in LR0 construction, we say directly conflict, but here we don't say. What we say, if both are present in the same state, we will check additionally. Check if T belongs to follow of Y, then we say SR conflict. Otherwise we don't say now. Previously we were not checking. The one means you need to compute follow set, right? We can compute the follow set very simple by looking at whole grammar. Who is the follow of Y? So look at, is T present? The follow of reduced item. Remember that the T belongs to shift item. Y, follow of Y is the belongs to reduced item. And reduced means x to alpha dot, y to, let's say, beta dot. Both reduced items are there. Then what do? Check follow of x intersection follow of y. Do you have any common terminals? If you have, then there is a conflict. Not equal pi, then we say there is a common terminal between follow of x and follow of y, then we say RR conflict exists in SLR1. Guys, and take these rules, and tomorrow we can practice this. And today I'm going to explain on this example. Is it LR0? Is this LR0? No. But now if you want to check SLR1, how do you do that, guys? Look at, we have S derives dot A, we have S derives dot. Both are present in, right? Both are present in I1, let's say I0, I0, I1, I2. In I0, we have this situation. So what do? Is this A? Is A belongs to follow of this S? We have to look at follow of this S. Check it. First compute follow of S in the grammar. In the grammar, we have only dollar. we have only dollar. So A does not belongs to follow of S. That is the reason it is not going to produce this SR conflict in LR0, but no conflict in SLR1. So this grammar is SLR1, guys. Similarly, we can go to the previous one. Now look at the I4 has RR conflict in LR0. Now how do you check that? Follow of A. In SLR1, how do you check that? Compute follow of A and follow of B, do the intersection. Tell me the answer. Looking at the grammar, why simple LR1? Because look at the grammar. What is the follow of A? It is just B. And what is the follow of B? Just C. Just C, guys. So here equal to pi means you don't have a common terminal. You don't have a common terminal. So there is no conflict. There is no conflict, no RR conflict in SLR1. So we say this grammar is SLR1, right? So we are going to practice this again tomorrow, but learn today we have seen, guys, and we have many examples to practice. Okay, we will practice again SLR1, then we will go for LLR1 and CLR1. LR0, SLR1 grammar, what is the relation? Both uses the same diagram, but the way you check the conflicts are different. Both uses the LR0 items only. LR0 items only used for both. But the way you check the conflicts are different. SR and RR conflicts, right? Checking is different. Same diagram we use. You can use the same diagram for both. We use the same set of LR0 items used for both. And summary, today we have understood, guys, how to construct the LR0 DFA. And that LR0 DFA we use for to check LR0 CFG, and it is also used to check SLR1 CFG. But how do you check? How do you check? There the SR and RR conflicts, we use the different formula for both and we check them. And in the next class I will be helping how to understand LLR1 and CLR1 along with these two. Okay, guys. And guys, you can follow me on Unacademy. That is unacademy.com/DEVAGATE, and you are aware of that. We have a very good subscription plan that is iconic. It is going to be very popular on Unacademy, which is introduced in the last month. And really, whoever aiming the GATE exam, competitive exams, please subscribe to Iconic. Even though price is little bit higher, but you will get lot of benefits compared to any online platform. This Iconic Unacademy plan is the best. And thank you so much, and follow other classes on this channel, and see you guys. Take care, and please, before leaving this session, don't forget to like and share with your friends and subscribe, and refer this DEVALIVE referral code if any of your friends want to join Unacademy. Thank you so much. See you guys. Take care. Bye bye.